The Embraer 145 is equipped with a fully integrated 3-axis Autoflight system. The Autoflight system is divided into two subsystems, the Autopilot system and the Flight Guidance System. The Autoflight system on the Embraer 145 consists of 2 Flight Director modules and 1 Autopilot module. The 2 Flight Director modules are housed in the 2 integrated computers, while only the integrated computer number 1 incorporates an Autopilot module. Optionally, the integrated computer number 2 can also incorporate an Autopilot module, but even so, only the left integrated computer Autopilot module will be active. Control functions for the Autoflight system are achieved through a flight guidance controller located on the glare shield, an Autopilot controller located at the center pedestal, and 3 switches located on each control wheel. The aileron and elevator servo motors will be found underneath the cockpit floor, while the rudder servo motor is mounted at the aircraft tail section. The Autoflight block diagram shows the basic architecture of the Autoflight system. The left integrated computer, which incorporates the left flight director module and the Autopilot module, receives power from the Avionic Master DC Bus 1A. The right integrated computer, which houses the right flight director module, is supplied by the Avionic Master DC Bus 2A. Each integrated computer receives information from both side aircraft sensor systems. For example, the inertial reference system, the micro air data computers, the enhanced ground proximity warning system, and the dual flight management system. Navigation data is sent to the integrated computers through the Primus 2 radio system buses. To show flight director information and messages, the integrated computers supply information to the display units. Finally, the converted flight guidance steering commands will be output from the integrated computers to the servos and the pitch trim system. The flight guidance system information will be displayed on the primary flight displays. This displayed flight guidance information is called the command bars. They give the references for the flight path to the flying pilot. When the autopilot is flying the aircraft instead of the pilot, these flight guidance commands will be converted into servo actuations. To operate the Autoflight system, the electrical buses have to be energized, and the avionic master switches must be selected to the on position. Most of the information related to the Autoflight system will be seen on the primary flight displays. In the mode enunciator area, the different autopilot modes will be seen. The lateral modes are shown on the right side, and the vertical modes are shown on the left side of the mode enunciator area. The armed modes will be displayed in white, while the captured modes are displayed in green. A flight director couple arrow in the center of the mode enunciator area indicates to which flight director the autopilot is coupled. If the Cat 2 condition is stabilized, a green Cat 2 legend will be seen. In case a signal becomes invalid afterwards, the green Cat 2 legend changes to an amber Cat 2 legend. The Autoflight system consists of the following main components: the 2 integrated computers located under the cockpit floor, a flight guidance controller, which is located at the glare shield, a pitch and turn controller located at the control pedestal, 2 go-around switches, 1 located on each thrust lever, 2 quick disconnect buttons, 1 on each control wheel, 2 touch control steering buttons also located on the control wheels, and 3 servo motors to act on the aileron, elevator, and the rudder control surfaces. For display purposes, the Autoflight system makes use of the primary flight displays and the engine indicating and crew alerting system display. The Flight Director subsystem provides pitch and roll attitude commands, which are based on data received from a variety of aircraft sensors, including attitude, heading, air data, radio altimeter, navigation, and pilot inputs. These attitude commands are then forwarded to the primary flight display and to the Autopilot module. The Autopilot subsystem automatically controls the aircraft control surfaces. For this, the Autopilot provides yaw stabilization and tracking of pitch and roll commands. The stabilization of the rudder is performed through the yaw damper, which is also part of the Autopilot module. This yaw damper function can be used with or without the Autopilot. The necessary information for the Autopilot to control the flight control surfaces is received from the flight director system. After the Autopilot has processed the incoming data, outgoing commands will be forwarded to the servos to convert the flight director data into servo motor actuation. An Autopilot yaw damper monitor continuously checks the Autopilot function and operation. Whenever there is a failure detected, it is capable of disengaging the Autopilot and the yaw damper. Finally, the comparison monitor subsystem compares the displayed pitch, roll, heading, glide slope, localizer, airspeed, altitude, and radio altitude information through the internal communication bus with the cross-side data. The Flight Guidance Controller is responsible for controlling both the flight director and the Autopilot. The front face of the Flight Guidance Controller provides the necessary buttons and control knobs to engage the Autopilot and yaw damper, select the flight director modes, couple the Autopilot, control the course, heading, vertical speed target, indicated airspeed or Mach targets, and the altitude preselect operation. All selected flight director modes will be enunciated by a lighted green bar on the selected button and will be shown on the primary flight displays in the mode enunciator area. On the outer left and outer right part of the Flight Guidance Controller are controls for the electronic flight instrument system functions. Two flight director buttons are used to select and deselect the display of the on-side flight director command bars. Two course selectors are provided for setting the on-side course pointer. If the course selector is turned, the course pointer on the primary flight display will move accordingly. Pushing the inner knob will cause the course pointer to show the selected station. On the center part of the Flight Guidance Controller, you find the buttons which control the Autopilot yaw damper engagement and disengagement logic. The Autopilot button, when pushed once, will engage the Autopilot and the yaw damper. Pushing the button again disengages the Autopilot, while the yaw damper stays engaged. Flight director mode selection is accomplished by using the flight guidance controller. The selectable modes are of two types, the lateral modes and the vertical modes. The lateral modes are the heading hold mode, the VOR nav hold mode, and the low bank mode. The vertical modes are the altitude hold mode, the flight level change mode, the speed hold mode, and the vertical speed hold mode. The approach mode is a combined lateral and vertical mode. The last selectable mode is the go-round mode, which is selected through the go-round buttons on the thrust levers. Enunciation of the active modes is provided by illuminated bars inside each button and by legends on the primary flight display in the mode enunciator area. In addition to the mode buttons, there are 3 control knobs on the flight guidance controller. An altitude pre-select knob, which allows the selection of the pre-select altitude in 100-foot increments, a vertical speed control knob, and indicated airspeed Mach selection button, which, when pressed, toggles between the speed modes Mach and indicated airspeed, and when rotated allows selection of vertical speed in 100-foot per minute increments if the vertical speed mode was pre-selected. When the speed mode was selected, it allows selection of airspeed in 1 knot increments, or Mach numbers in 0.01 increments. Finally, a heading knob is found on the flight guidance controller, which is used to select heading in 1 degree increments, or when pressed, synchronizes the heading select to the current displayed heading. 2 control wheels are installed in the cockpit. Each control wheel has an Autopilot quick disconnect button, a touch control steering button, and a pitch trim switch. When either one of the Autopilot quick disconnect buttons is pushed, the Autopilot and the yaw damper will disconnect. At the same time, an aural warning Autopilot will be heard. To cancel this alarm, push the Autopilot quick disconnect button a second time. Pushing the touch control steering button allows manual maneuvering of the airplane to any pitch attitude without disengaging the Autopilot. After the button is released, the primary servos will re-engage and the computer will synchronize to the new pitch attitude. Manual trimming of the aircraft is performed through the pitch trim switches. The operation of a pitch trim switch will disengage only the Autopilot while the yaw damper remains engaged. The Autopilot controller is used to manually control the Autopilot. For this purpose, a pitch wheel and a turn knob are mounted on the Autopilot controller. Rotating the pitch wheel with the Autopilot engaged changes the pitch attitude proportional to the wheel rotation. Rotating the turn knob out of détente with the Autopilot engaged commands a roll attitude change. The roll angle is changed proportional to the rotation of the turn knob. Rotating the turn knob cancels any other lateral mode, and returning the turn knob into the détente position enters the Autopilot into the heading hold mode. Note that the turn knob must be in the détente position before the Autopilot can be engaged. Most of the information related to the Autoflight system will be seen on the primary flight displays. In the mode enunciator area, the different Autopilot modes will be seen. The lateral modes are shown on the right side, and the vertical modes are shown on the left side of the mode enunciator area. The armed modes will be displayed in white, while the captured modes are displayed in green. A flight director couple arrow in the center of the mode enunciator area indicates to which flight director the Autopilot is coupled. If the Cat 2 condition is stabilized, a green Cat 2 legend will be seen. In case a signal becomes invalid afterwards, the green Cat 2 legend changes to an amber Cat 2 legend. At the top of the attitude sphere, the Autopilot and yaw damper status are displayed. As long as the Autopilot test mode is active directly following power-up, a green Autopilot test indication will be seen. A green Autopilot and yaw damper legend indicates that both the Autopilot and the yaw damper are engaged. An amber Autopilot and yaw damper legend will indicate a normal disengagement. A red Autopilot legend indicates that the Autopilot is disengaged, and a failure occurred at the same time. Additionally, an autopilot fail message will be seen on the engine indicating and crew alerting system display. If the yaw damper is engaged and a failure occurs, the yaw damper legend will flash for 5 seconds in amber and then become steady. Both the autopilot fail and the yaw damper fail messages can be cleared through the quick disconnect buttons on the control wheels. The following additional Autoflight information can be seen on the autopilot status field. A TCS legend to indicate that the touch control steering submode is engaged, and a turn knob legend in amber to indicate that the turn control knob is out of détente. Finally, in the center of the attitude sphere, the flight director command bars will be found if selected to on. In case the flight director fails, the command bars will be removed, and instead, a flight director legend is displayed in the mode annunciator area of the primary flight display. In addition to the indications on the primary flight display, there are also Autoflight-related messages on the engine indicating and crew alerting system display. Whenever the autopilot fails, a red autopilot fail warning message will be seen. An amber autopilot caution message indicates that the autopilot had a power-up failure. A yaw damper failure is indicated by an amber yaw damper fail caution message. In case the automatic pitch trim function is inoperative, an amber auto trim fail caution message will be displayed. If excessive autopilot pitch or roll commands are required, this will be indicated by amber mistrim caution messages. Whenever there are lateral or vertical modes deactivated due to loss of the required data, this will be indicated by an amber lateral mode off or vertical mode off caution message. To prevent an abrupt roll command at the time a roll mistrim exists and the autopilot is disengaged, an amber mistrim arrow will appear inside the roll scale, in conjunction with the amber autopilot aileron mistrim caution message. Most of the information related to the Autoflight system will be seen on the primary flight displays. In the mode annunciator area, the different autopilot modes will be seen. The lateral modes are shown on the right side, and the vertical modes are shown on the left side of the mode annunciator area. The armed modes will be displayed in white, while the captured modes are displayed in green. A flight director couple arrow in the center of the mode annunciator area indicates to which flight director the autopilot is coupled. If the Cat 2 condition is stabilized, a green Cat 2 legend will be seen. In case a signal becomes invalid afterwards, the green Cat 2 legend changes to an amber Cat 2 legend. The roll-hold submode is entered from the heading hold mode, with the autopilot engaged by using the touch control steering button to manually fly the airplane to a bank angle greater than 6 degrees. The system will maintain the bank angle at the time the touch control steering button is released. The roll-hold submode may be cancelled by either manually flying the airplane to less than 6 degrees with the touch control steering button, by moving the turn control knob out of détente, or by selecting another lateral mode. The turn knob submode allows the pilot to generate a roll attitude command manually with the turn control knob. Moving the turn control knob out of détente with the autopilot engaged cancels all other lateral modes. The autopilot will maintain a roll attitude proportional to the displacement of the turn control knob. The autopilot will revert back to heading hold mode when the turn control knob is placed back in the détente position. Turn knob submode is enunciated on the PFD through a roll legend and a turn knob legend when the turn control knob is out of détente and the autopilot is disengaged. The wings level submode provides a roll command of 0 degrees. This mode is active in the go-around mode, or if the displayed heading is invalid. Therefore, this mode is available even if either inertial reference system signal is invalid. This mode is enunciated on the primary flight display through a roll legend. The heading select mode is used to select and intercept a magnetic heading. It is indicated by an HDG message on the primary flight display. The heading bug selection is done through the heading knob on the display controller. The maximum angle of bank during a turn is limited to 27 degrees. However, by pushing the bank button, the maximum angle of bank can be limited to 14 degrees in the heading select mode. The heading select mode is cancelled by either pushing the heading button again, by the automatic capture of any other lateral mode, by coupling to the cross-side flight director, or by the selection of the go-around button, or on ground. Selecting the navigation button on the flight guidance controller allows automatic interception, capture, and tracking of the selected VOR, or localizer, signals. The VOR mode is selected by first tuning the desired VOR frequency in, and then pushing the nav key on the flight guidance controller. If the nav button is pushed and the aircraft is outside the normal VOR capture range, a white VOR armed annunciation will appear on the primary flight display. When the airplane now approaches the selected course and enters the capture phase, the green heading capture and the white VOR armed message will extinguish, and a green VOR capture message will flash for 5 seconds. The flight guidance computer will now generate the proper roll commands to track the selected radial. The nav mode will be cancelled or inhibited if any of the following actions are taken or conditions are present. Pressing the nav key again. Selecting a different lateral mode. Changing the displayed navigation or heading source on the primary flight display. When the displayed nav or heading is invalid. When the go-around button is pressed. Or whenever the turn control knob is moved out of détente. The VOR approach mode works in the same way as the VOR navigation mode, except for a higher gain setting for the operation close to the stations. The approach mode is selected by pushing the approach key on the flight guidance controller. The approach mode will then be indicated by a VOR legend displayed on the primary flight display. The localizer mode is selected by first tuning in the desired localizer frequency, and then pushing the nav or approach keys on the flight guidance controller. At the point of capture, the current armed mode is selected, locked, and the heading mode is cancelled. The localizer mode can be cancelled or inhibited by pushing the nav, heading, or approach buttons. Changing the navigation source for the coupled primary flight display. Coupling to the cross-side flight director. Changing the symbol generator driving the coupled primary flight display. Selecting the go-around mode. If the displayed nav, attitude, heading is invalid. Or when the turn control knob is moved out of the détente position. The long-range navigation mode allows the flight director to capture and track the roll steering signal from the long-range navigation system. Selecting the long-range navigation mode is accomplished by pressing the nav button on the flight guidance controller, with FMS selected on the primary flight display. Selecting LNAV will automatically capture LNAV if the steering command is valid. The mode will be cancelled or inhibited if any of the following actions are taken or conditions occur. The nav button is pushed. The Autoflight system will operate in different vertical navigation modes. The pitch hold mode is the vertical default mode and is enabled when no other lateral mode is selected and the autopilot is engaged. If these conditions are satisfied, the airplane will maintain the pitch attitude and a pitch annunciation will be displayed on the primary flight display. The aircraft pitch angle can be changed either by turning the pitch wheel or by pushing the touch control steering button on the control wheel. The altitude hold mode is used to maintain a barometric altitude. To select altitude hold, the pilot can either push the altitude button, which will cancel any other previously selected vertical mode, or the mode is selected automatically by means of the altitude pre-select mode. The aircraft will maintain the barometric altitude at the time of selection. The altitude may be changed by the use of the touch control steering button on the control wheel. The altitude hold mode is cancelled by pushing the vertical speed, the flight level change, the altitude hold, or the speed mode button. Coupling to the cross-side flight director, moving the pitch wheel, changing the symbol generator driving the coupled primary flight display, selecting Go Around, or a failure of the coupled air data computer will also cancel the altitude hold mode. The altitude select mode is used in conjunction with other vertical modes to automatically capture, level off, and hold a selected altitude. First, the desired altitude has to be selected on the primary flight display. Now, the climb or descent to the new altitude has to be initiated. And in addition, another vertical mode, such as vertical speed or flight level change, also has to be selected. The primary flight display will now display altitude select in white and the other vertical mode in green. As the airplane approaches the selected altitude, the altitude select mode is captured and the indication will change to green. The airplane will remain in the capture mode until the aircraft is within 25 feet of the selected altitude and the vertical speed is less than 5 feet per second. At this time, the system will switch to the altitude hold mode. The flight level change mode is used for flight level changes. The flight level change mode is selected by setting the preset altitude to the desired value, and then pushing the flight level change mode button. This will now cause the system to climb or descend towards the selected value with a preset speed provided by the flight director. The target speed is shown on the primary flight display through the indicated airspeed. When the aircraft approaches the preset altitude, the flight director will cycle through altitude select arm, altitude select, and altitude hold to capture the preset altitude. The flight level change mode is cancelled by capturing the selected altitude. The speed hold mode is used to maintain airspeed or Mach number while flying to a new altitude to obtain cruise altitude after takeoff and for VMO or MMO descents. Indicated airspeed is used below 25,000 feet, and Mach number will be used above 25,000 feet. The speed hold mode is selected by pressing the speed button in the flight guidance controller. The selection of speed hold mode cancels other vertical modes, except the altitude preselect arm mode and glide slope arm mode. Speed hold mode is automatically selected when the flight level change button is pressed and the preselected altitude is above the current altitude. The vertical speed hold mode is used to select and hold a desired vertical speed. When the vertical speed button is pushed, a green vertical speed message will appear on the primary flight display, and the flight director will command the required pitch angle to hold the selected vertical speed. The vertical speed can then be changed by the use of the pitch wheel, the speed knob, or the touch control steering button on the control wheel. The vertical speed mode can be cancelled by either pushing the vertical speed, flight level change, or speed button, by coupling to the cross-side flight director, by changing the symbol generator driving the primary flight director, or by selecting Go Around. The glide slope mode allows automatic capture and tracking to glide slope transmitter signal. Selecting glide slope mode is accomplished by pressing the approach button with an ILS frequency selected. The mode will be cancelled or inhibited if any of the following conditions occur. The approach or nav buttons are pressed. The localizer mode is lost. By pushing the go-around buttons on the power levers, the go-around mode is initiated. This will disengage the autopilot and yaw damper, and cancel all flight director modes. Thereafter, roll as the lateral mode and takeoff as the vertical mode will be shown. In addition, a 10-degree nose-up and a wings-level flight director command will be displayed on the primary flight display. The go-round mode can be canceled by pushing the touch control steering button, by selecting another vertical mode, or by engaging the autopilot